Hello students, hope you are doing well and hope you have followed all the previous videos that I've made on Get My Classes on this particular topic and other topics as well. So in this video, we'll be looking into the concept elasticity. The subtopics that we are going to go through are stress and strain. We'll try to understand what is stress and what is strain. Then we'll look into Hooke's law and then Young's modulus, then elastic potential energy, and then we'll try to understand what is Shear's modulus and bulk modulus, and finally Poisson's ratio. So now let's try to understand what is stress. When a body deforms under deforming force, internal restoring forces called elastic forces are produced. These restoring forces per unit area are called stress. Now stress can be classified into various categories. The first one is normal stress. Now under what condition normal stress comes into picture? Now let me take an object something like this. If I apply a force F on this and this is the area of cross section, then F by A is called normal stress. So normal stress at any section is the ratio of component of force acting perpendicular to the section to its surface area. The next thing that we have is shearing stress. It is the ratio of component of force acting parallel to the section to its surface area. So what do I mean by that? So I'll just try to explain shearing stress here. Now let's say I have an object like this, a cubical object. I'll take a different color. So I apply a force F on this. Now due to this, what will happen? The upper surface slides a bit on the lower one. Now this force by this area is called shearing stress. So I can say F by A, force by area which is parallel to it or tangential to it. Then we have volume stress. Volume stress is change in pressure, that is delta P. Now, or I can write it as delta V by V. Change in delta V by V is volume strain. So delta P is volume stress. So under what condition volume stress comes into picture? Volume stress comes into picture when there is stress applied on the volume of an object, or when the volume of the object is being changed by pressure. The net pressure acting on it is responsible for the change in volume, and that's called volume stress. The next thing that we have is strain. The ratio of change in dimension to original dimension is known as strain. Now again, strain is also classified into various categories. The first one is longitudinal strain. Now longitudinal strain is like if I have an object of length L, I extend this by a small length L, delta L. Now longitudinal strain is delta L by L. So longitudinal strain is change in length by original length of the object. Then we have shear strain. Now very similar to shear stress, when I have an object, now because of application of force, this object has been deformed like this. So this is delta L and this is L. So this delta L by L is called shearing strain. If I take this as theta, we know that for small angles tan theta is almost equal to theta. So if delta L is very much smaller than L, I can write tan theta equal to delta L, or that would imply theta equal to delta L by L. So shearing strain can be equal to theta for small values of change in length. Now volume strain is change in length by initial volume. This is what is volume strain. Now let's look at Hooke's law. If we study the behavior of any object, elastic behavior of any object by drawing a graph between stress and strain, we call it as stress and strain curve. Now for some finish from initial point till some region, there is a linear relation between stress and strain, that is stress is directly proportional to strain. So till that point we call it as elastic limit. Now after that, what we see that there is more strain produced for small change in stress, and so this keeps on going to a maximum point, and then for a very small change in stress, for even when we don't apply a force, even if stress is not applied, there is a strain produced. So these are various names given to that. This point is called yield point, and then we have breaking stress, the stress at which the object breaks, that's called breaking stress. Then elastic limit is the limit till which the object, if deformed, regains its original dimensions. Then we have proportionality limit. Proportionality limit is the limit till which the stress and strain are proportional to each other. Now coming to Hooke's law. Hooke's law is only valid within elastic limit. Now what is elastic limit? Elastic limit is the region in which stress is directly proportional to strain, or in fact that is what is elastic limit is the region till which if an object is deformed it will get back its original dimension. So Hooke's law says that within elastic limits stress is directly proportional to strain. So I can write stress is directly proportional to strain, or this can be written as stress by strain equal to constant. So this is what is Hooke's law. Now based on this Hooke's law we define various rigidity modulus. The first one is Young's modulus. Now Young's modulus is defined as longitudinal stress or normal stress by longitudinal strain. So it is longitudinal stress by longitudinal strain. This is Young's modulus. So how do I write it? I can write y equal to F by A, that is longitudinal stress, by delta L by L. So from this I can write delta L equal to FL by AY. So if a force F is applied normal to the cross section, then the change in length of the object is given by FL by AY. So Young's modulus, you can see that it will have dimensions of pressure because strain doesn't have any dimensions. So in this way, so Young's modulus, now what does Young's modulus tell us about? Now if an object is having greater Young's modulus, it is difficult to change its length. And if an object is having lower Young's modulus, then it is easier to change its length. So I can define Young's modulus to be the measure of opposition to change in length of an object. So I hope you could understand. So that's what is Young's modulus. Now let's see elastic potential energy. Of course there is a mistake in this figure. Now when we talk about elastic potential energy is like if there is an object, something of this kind, and upon application of force this changes by delta L. Now whatever work is done in changing the length of the object is stored as potential energy of the object. So whatever work is done in changing the length of the object, it is stored as potential energy of the object. So if I want to find out what is the energy stored in this, I will not get into the derivation of it, I will directly say that. So the elastic potential energy stored in an object is given by half into stress into strain into volume of the object into volume. So what is volume? Area into length. So this is energy. Now energy per unit volume is given by half into stress into strain. Now energy per unit volume, which is half into stress into strain, this is called energy density. So here we are defining it in terms of half into stress into strain, but this can be defined in terms of Young's modulus also. Now stress by strain is y, so this can be written as y, so Young's modulus into strain square. This is one way, or this can also be written as half into strain is stress by y, so stress square by y. So depending on which the given parameters, I can find out what is the energy per unit volume, and if I know what is the energy per unit volume, I can find out what is the work done or the potential energy stored in the or elastic potential energy stored in the system. After that we have Shear's modulus. Now Shear's modulus is tangential stress by tangential strain. So I can write shear modulus, we represent it by sigma. Shear's modulus we represent it by sigma. Sigma equal to, I can write it as tangential stress by tangential strain. So this is tangential stress by tangential strain. This is sigma. So that can be written as F by A by delta X by L. Now F by A is the force that is shown. As we have discussed that delta X by L can be represented by tan theta, but when delta X is very small, tan theta is almost equal to theta. So I can write this as sigma equal to F by A theta. Now Shear's modulus, if Shear's modulus is more, then it is very difficult to change the shape of the object. So I can say Shear's modulus is the opposition or measure of opposition to change in shape of the object. So if Shear's modulus of object is very small, then its shape can be easily changed. Then we have bulk modulus. Now in order to understand bulk modulus, let's assume that I have a container and I have a fluid in it. Inside, I apply some force on this. Now, this fluid will apply pressure in all the directions. Now, due to the application of pressure, then what is happening is, due to the excess pressure that is applied on this object, there is a change in volume of this. So, this bulk modulus is defined as excess pressure by volume strain. So, this is what is bulk modulus. So, bulk modulus can also be written as delta PV by delta V. This is what is bulk modulus of an object. So, if bulk modulus is more, then it is difficult to change the volume of the object, or an object with lower bulk modulus can easily undergo change in volume. Apart from this, we have something called Poisson's ratio. Now, when we are changing the dimensions of the object, it's not necessary that the density of the object changes. So, if the density of the object is more or less same, then increase in one dimension would result in decrease in other dimension. So, Poisson's ratio takes care into the relative changes of dimensions in various directions. For example, if I take this, if I am increasing the length of the object, what is happening? The width decreases. Similarly, if I am decreasing the width of the object, what will happen? Length decreases. So, Poisson's ratio is given by delta d by d. I will say delta d by d by delta L by L. So, with the negative sign. The negative sign implies that if one part increases, the other part decreases. So, in words, I can write P equal to negative of lateral strain. Lateral strain is strain perpendicular to the surface by longitudinal strain. So, effectively, the value of Poisson's ratio lies between 0 and 1. Sorry, 0 and 0.5. Practically, the values of Poisson's ratio is seen to be existing between 0 and 0.5. So, this is what is there in elasticity. We have seen the synopsis of elasticity. For a quick review, what we have seen, what is elasticity, we have defined what is shear, what is stress, what is strain. Then we looked into various types of stress as well as various types of strain, longitudinal stress, superficial stress, volume stress. Similarly, what we have is longitudinal strain, then shear strain and volume strain, and then we defined Hooke's law. Hooke's law is stress is directly proportional to strain with an elastic limit. Then we looked into various rigidity modulus. Young's modulus gives us the ratio of normal stress to normal strain, and then shear's modulus, it gives us the ratio of tangential stress to tangential strain, and bulk modulus gives us the ratio of volume stress to volume strain. So, this is what is there in this particular part. Hope you could follow whatever we had done. Thanks a lot for watching this video and also watching the other videos of Get My Classes. Thank you very much for following Get My Classes. Thank you once again.